So in this video we are going to discuss about step response of series RLC circuit, or I may call it as forced response of series RLC circuit, or I can say the driven response of series RLC circuit. Okay. So what is the difference here is we will be having a source which is connected. Okay, the source which is connected always. So always there is a connection of a source, okay, to the RLC series circuit. Okay, so the response will be changed due to this. Usually the transient response will die out after some time, but if I have the source like this, it will not happen. Okay, so let's consider this. The step response is obtained by the sudden application of DC source. Okay, we'll be applying it as a sudden application of DC source. Okay, let us consider this. Apply KVL for t greater than 0. Okay, at t equal to 0 it is getting closed. For t greater than 0, RLC will be there and there will be a source also connected. Okay, this voltage across this will be IR. So voltage across this will be L di by dt. Okay, and voltage across this will be V. Okay, so L di by dt plus Ri plus V and then minus Vs equal to 0. Okay, if I apply KVL around the loop, so minus Vs plus IR plus L di by dt, L di by dt. Okay, the current is entering positively, so plus V equal to 0. Okay, so now I am just rearranging it. L di by dt plus Ri plus V equal to Vs. Okay, let us consider I is equal to C dV by dt, current voltage relationship of a capacitor. I equal to C dV by dt. Now substitute. Okay, now substitute that in that equation. All the i's will be replaced with C dV by dt. So we get LC d by dt of dV by dt will become d square V by dt square. Okay, plus R C d by dt, sorry, dV by dt plus V equal to Vs. So now I am going to divide by LC. If I am dividing by LC, this will be cancelled. We get d square V by dt square. So RC by LC, CC will get cancelled. R by L dV by dt plus V by LC equal to Vs by LC. Okay, here it is almost similar to what we have derived earlier, but only difference here is the voltage. Okay, the voltage source. Okay, added to it, that is the difference. So the total response will be due to the transient response plus steady state response. So both has to be considered. So for the transient response, for the three different cases, overdamped, underdamped and critical damped, is similar to what we discussed earlier. V of t equal to a1 e power s1 t plus a2 e power s2 t. V of t equal to a1 plus a2 t e power minus alpha t. And for underdamped, V of t equal to a1 cos omega dt plus a2 sin omega dt e power minus alpha t. So this is for transient response. So along with that, the steady state response also to be added in the step response. So the formulas which I am using here will be almost same. Okay, almost same. Okay, we are going to add the steady state response. See, if you see, the formulas are similar to parallel RLC. Okay, source response of parallel RLC. So I need to add this Vs. Okay, steady state response Vs along with this formula. So V of t equal to Vs plus a1 e power s1 t plus a2 e power s2 t, and V of t equal to Vs. All the formulas Vs is added. Okay, that is the only difference in this formula. This is step response of series RLC. Step response of series RLC. Okay, we'll discuss a problem along with this. For the circuit shown in the figure, I am not going to discuss all the cases. I'll just teach one or two cases, and remaining case I'll simply go through. Okay, you can do it on your own because same application it will be repeated. Okay, so for the circuit in the figure below, find V of t and I of t for t greater than 0. For the circuit is shown here, find V of t and I of t. We need to find V of t and I of t. for t greater than 0. Consider the cases r equal to 5, r equal to 4 and r equal to 1. 3 cases are given. So at t equal to 0, this switch is getting opened. It means before that it was closed. So capacitor will act as a open circuit when reach a steady state, and inductor will act as a short circuit. My circuit look like this at steady state. So when I reach the steady state, just before the switch is opened, which is t equal to 0 minus, I am going to reach the steady state. So at t equal to 0 minus, my circuit look like this. Okay, my circuit look like this. So everything will be there. The inductor act as a short and capacitor will act as a open circuit. So that I can find out voltage across this 1 ohm as voltage across the capacitor at steady state, and current through this will be the initial current of the inductor. So I of 0 minus will be equal to 24 by 5 plus 1, 6. Okay, 24 by 6. So 24 by 6 will be 4 ampere. So I of 0 is calculated. And V of 0 minus is the voltage across the 1 ohm resistor. So V of 0 minus is equal to 1 times I of 0 minus, which is 1 times 4 will be 4 volt. So V of 0 also identified. At t equal to 0, what happened? This switch is opening. So this part of the circuit is removed, and we have R, L, C in series with the 24 volt source. Okay, R, L, C in series with 24 volt source. Okay, we know what is Vs. Vs is 24 volt. R value can be considered 5 for case 1. L value is 1 Henry and C value is 0.25 farad. Okay, 0.25 farad. So find out what is alpha. Alpha equal to R by 2L. Okay, for series RLC it is R by 2L. Okay, just check the formula for parallel RLC, it is different. Okay, so omega naught equal to 1 by root LC. Okay, substitute R and L will get 2.5, substitute L and C will get 2. So you can see alpha is greater than omega naught. It is overdamped case. For overdamped case, what is the formula? For every cases Vs should be there, plus A1 e power S1t e power S2t. Let us see whether it is correct or not. Okay. So you have to equal to VSS or Vs plus A1 e power minus t plus A2 e power, A1 e power S1t plus A2 e power S2t. So we need to find out what is S1 and S2. Based on the value of alpha and omega naught, I can find out what is S1 and S2. So the formula is minus alpha plus or minus root of alpha square minus omega naught square. It is common in the case of RLC circuits. Okay, minus alpha plus or minus root of alpha square minus omega naught square. If I substitute that, I am getting this two answers. S1 equal to minus 1 and S2 equal to minus 4. Okay, substitute that, we will get V of t equal to Vs. So we can substitute 24 also here, plus what is A1? A1 we don't know. E power S1 is minus 1 into t plus A2 e power minus 4 times t. Okay, that is what we got here in the equation number 2. Okay, now I need to find out A1 and A2. So in order to find the A1 and A2, first substitute t equal to 0. Initial condition to be considered for finding out the constants. So V of 0 equal to 24 will be written as it is, A1 will be written as it is, e power 0, A2 will be written as it is, and e power 0. E power 0 is 1, we get 24 plus A1 plus A2, and V of 0 is 4. Okay, so we'll get A1 plus A2 equal to minus 20. Okay. So we know that the current through the inductor cannot change abruptly, and the same current through the capacitor at t equal to 0. Okay, current through the inductor and current through the capacitor both are same at t equal to 0. So I already know the current through the inductor, which is I of 0. Okay, which is equal to C dV by dt. So dV of 0 by dt is equal to what? I of 0 by C. Okay, so I of 0 by C. I of 0 is 4, by C is 0.25, we will get 16. So dV of 0 by dt is 16. Now differentiate the equation which we got. equation number 2 I need to differentiate. So dv of t by dt equal to 24 will be differentiated to 0 because it is a constant, plus a1 e power minus t can be differentiated as minus 1 e power minus t, e power minus 4t minus 4 e power minus 4t. Okay, we can write this. So dv of t by dt, constant is differentiated to 0, a1 is a constant, e power minus t is differentiated as minus 1 e power minus t, plus a2 minus 4 e power minus 4t. Now substitute t equal to 0. So I will be getting the equation like this, 16 equal to minus a1 minus 4a2. So we have two equations, two unknowns. We can solve it. I will get a1 equal to minus 21.334 and a2 equal to 1.334. Okay, so v of t will be 24 plus within bracket minus 21.334 e power minus t plus 1.334 e power minus 4t. So this is the current, this is the voltage. Okay, this is the voltage which you got. And then next we need to find out the current. Since the inductor and capacitor are in series, here in the inductor and capacitor are in series, for t greater than 0, the inductor current is same as capacitor current. Both will be same because it is series. So I of t is equal to c dv by dt. Okay, I of t equal to c dv by dt. So I of t equal to c d by dt of the voltage value is to be substituted. And differentiate the equation with respect to t. Differentiate the equation with respect to t. I will be getting the current I of t. So I will be getting the current I of t. Just go through this differentiation process. Okay, this point is very important to remember, otherwise my solution will be complicated. See, the inductor and capacitor both are series. The current flowing through the inductor is same as current flowing through the capacitor. So I know voltage across a capacitor, so I can directly find out the current through the inductor by finding the current through capacitor. So the current voltage relationship here is I of t equal to c dv by dt. We know this v. Okay, substitute that v here, differentiate it once, okay, and then multiply with c. You will get the current I of t. Case 2 and case 3 you can do it on your own. I will simply explain what is happening. So only R value changes. If R value changes, okay, we need to find the initial voltage again. R value changes once. So this R value changes. So definitely it will affect all the values. Okay, so in case 2 R value is equal to 4. So I will be getting a circuit like this. Okay, I have drawn the same circuit what we did in the previous case, but the value of R is 4 ohms. Find out what is I of 0 minus and find out what is V of 0 minus. So V of 0 minus is the voltage across the capacitor, which is equal to the voltage across the resistor. I of 0 minus is current through this, okay, inductor, current through the inductor. So by having this value of R and L, find out what is alpha and what is omega naught. Here alpha and omega naught are same, so we can call it as critically damped. So find out the roots. S1 equal to minus alpha plus or minus root of alpha square minus omega naught square. My roots are minus 2. Okay, my roots are minus 2 plus or minus root 0. Okay, my roots are minus 2. So here alpha value is minus 2. So we can write total response is V of t equal to VSS need to be added plus A1 plus A2t close the bracket e power minus alpha t. So this is the formula. Okay, just substitute the VSS value and alpha value. We will be getting the equation like this: 24 plus A1 plus A2t e power minus 2t. So this is what we got. Now using the initial conditions, okay, we need to find the value. of A1 and A2. So substitute t equal to 0, and we know that v of 0 is 4.8. Substitute t equal to 0, so we get the equation like this: 24 plus A1 plus A2 of 0 e power 0. So 4.8 equal to 24 plus A1. A1 is minus 19.2, so we got A1. Next, for A2, we know that the current through the inductor and capacitor are same, so we are going to find the current through the capacitor. I of 0 equal to C dV of 0 by dt. Okay, so dV of 0 by dt is I of 0 by C. So 4.8 by 0.25, we will be getting 19.2. The answer is 19.2. Okay, now differentiate this equation. Okay, differentiate the equation which we got. So differentiate this equation with respect to t. So once you differentiate it, you will be getting so dV of 0 by dt, and this equation, substitute the t equal to 0 and find what is A2. Okay, and substitute the A1 and A2 in the equation. Okay, so that V of t is obtained. V of t is equal to 24 minus 19.2 times 1 plus t e power minus 2t volt. Okay, I am simply showing what I have done. Okay, all are simple mathematics, you also can try. Okay, the inductor current is same as capacitor current, so I of t can be written as C dV of t by dt. Okay, whatever equation we got, we just substitute here, perform the differentiation and multiply with the capacitor value, and we will be getting the current. Value. Okay, the last case you do on your own. I'll just show the problem. Just make a note of it and see. So just pause the video and write down. Okay, you can pause the video and write down. So I am not going to wait till you complete it. Okay, so just pause the video and write down. Thank you.